The anatomy of triangles made learning trigonometry much better for me.
I used to hate trigonometry because the books before were very difficult to understand.
But because of this book, I am more motivated to learn and master the concepts of trigonometry.
Oh, hi there. Are you tired of learning trigonometry through boring and difficult problems? Looking at diagrams and illustrations that absolutely don't make any sense? Have you spent all your money on books that cannot assist you in your academic needs? Well then, we have a solution for you.
The anatomy of triangles contains various of problems with step-by-step solutions in order to guide you throughout each concept.
It has even real-life applications in the field of engineering, architecture, and medicine.
That's right, Claire. Now let's switch to trigonometry. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. It helps us find angles, distances, and is used a lot in science, engineering, video games, and more.
So for our first example of a trigonometric problem with a real-life application, we tackle the topic of inverse trigonometric functions. This topic uses such methods to solve even a problem as bizarre as how a fire truck should be to a building with raging fire from its front in order to put out the fire. Our problem is a tower 28.4 feet high must be secured with a guy wire anchored 5 feet from the base of the tower. The problem is, what angle should the guy wire make with the ground? So to find the angle, we will use the trigonometric function tangent to find our theta with the equation opposite over adjacent. The opposite side of the theta here is the height of the tower, which is 28.4 feet, while the adjacent side of the theta is the guy wire anchored to the base of the tower with a length of 5 feet. So 28.4 height of the tower divided by the 5 feet guy wire will equal to 5.68. But that's not the angle we are looking for. We will use arctangent to find the missing angle. So, arctangent 5.68 is equals to 80.02 degrees. So in order to secure the 28.4 feet high tower, the guy wire needs to make an 80.02 degree angle.
Polar coordinate function. Our second topic is all about polar coordinate function, which applies to problems that involve engineering, such as from a physicist's point of view. Polar coordinates are useful in calculating the equations of motion from a lot of mechanical systems. To solve this problem, the point P is equal to R where theta is located R units from the pole. If R is greater than 0, the point lies on the terminal side of theta. If R is less than 0, the point lies along the vector opposite the terminal side of theta. If R is equal to 0, the point lies at the pole, regardless of the value of theta. Plot the points with the following polar coordinates. Now, to plot this point, begin with an angle of 135 degrees. Because 135 degrees is a positive angle, draw counterclockwise from the polar axis. Now consider R is equal to 2. Because R is greater than 0. Plot the point by going out 2 units on the terminal side of theta.
Trigonometric identities. Last but not least, our third topic dwells on trigonometric identities, which should apply on fields like oceanography, where you measure the tidal change using the trigonometric graph. So the problem is to prove the identity. To solve, use the identities in the left-hand side of the given identity.
Those are the examples from each topic that could totally make a difference in today's ever-changing society.
That's right. To wrap it all up, trigonometry has played a huge role in today's world full of complexity. Thankfully, our great forefathers have invented trigonometry in order to make today's and future scientists, mathematicians, physicists, and engineers' lives easier.